Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, which consists of myself, Isra Muhammad, Yasikal Adreni Ginting, and Adita Siti Farida, who will present the results of the big assignment of the oil and gas logistic course with our title, Optimization of Pertalite Product Distribution Routes using the branch and bound algorithm method to minimize mileage and distribution cost. Case study Integrated Terminal Semarang PT Pertamina Morfor. So, the first thing we will discuss is related to the introduction. As we know, PT Pertamina Persero is one of the state-owned enterprises or BUMN engaged in the energy sector including oil, gas, and renewable energy. In its operation, Pertamina has various branch offices throughout Indonesia, one of which is Pertamina Marketing Operational Region 4 located in Semarang City. One of the main facilities in this region is the Integrated Terminal Semarang, which plays a role in various activities related to the distribution of fuel oil or BBM, such as receiving, stockpiling, and distributing fuel to public fuel filling station or SPBU. The terminal is responsible for distributing fuel to 20 gas stations with a delivery limit of 24 kiloliter or KL trucks. In its distribution process, Integrated Terminal Semarang uses MS2 software, which is used to determine which gas station will receive fuel supplies. However, in practice, the selection of gas station is sometimes less than optimal, which can cause inefficiencies in terms of time and cost. Therefore, a study was conducted to determine a more effective distribution route, especially for pertalite fuel products. This research uses the branch and bound algorithm method, which aims to optimize the distribution process to be more efficient and targeted.
So the next is methodology. In methodology, we have a research method flowchart. There is literature study, problem identification and research objective formulation, secondary data collection, calculating the distribution cost of the existing route, processing new route data with branch and bound algorithm, analyzing the new route optimization result, calculating the distribution cost of the new route, comparison and analysis, conclusion and suggestion. Next, we have data collection. Here is data on Pertamina-owned gas station in Semarang. You can see that on the table. As we can see on the table, each gas station has their own code number. Next is results and discussion. Here we have an existing route table. The first step is to recalculate the distance of the existing route using a distance matrix with the help of Google Maps. This calculation is necessary due to differences in the method used in the reference paper, requiring adjustment to obtain a more accurate route distance. After calculating the distance matrix, the next step is to determine the mileage of the existing route based on the distance matrix that has been created and calculated the transportation cost for the existing route. So, based on the calculation of the distance of the existing integrated terminal Semarang route using MS2 software, a distance of 271 km was obtained. With this distance, the estimated full cost reached 418,695 rupiah, while the carbon emission produced amount to 827,634 grams of CO2 equivalent.
Application of Lingo software for new route determination. In the study, in determining the new route, we use Lingo software version 18 to find optimal solution for distribution routes by minimize travel distance using the branch and bound algorithm method. The model used in Lingo consists of several important components, namely nodes, which represent location point in the distribution network. The depot at the starting point is number 0. while the gas station servers are numbered 1 to 16. Link none and not describe the relationship between distribution point, which involves two main things: the road decision choice and the amount of demand at each gas station. In addition, there is a variable D that indicates the demand at each gas station and capacity, which indicates the maximum capacity of the vehicle. Next, analysis of output in Lingo software. Once the model is set up and run, the Lingo software generates output that includes the total distance traveled and the road decision choice. The resulting objective function shows the total distance traveled, which in this case is 253.2 km, which is the optimal solution for distribution. In the figure, one can see the value of the variable x, ij, indicating the route choice. A value of 1 means that the route is chosen, while 0 means that it is not. For example, x02 is 1, which means that the route from the depot node 0 to gas station 2, node 2 is selected. In the figure, the value of the variable yij indicates the number of goods saved via that route. Most of the values are 24, which means the full capacity of the vehicle is used for those routes. Next, calculation of transportation costs on new routes. The route generated by the Lingo software can be seen in the table on this slide. Based on the calculation, the total distance traveled for distribution is 253.2 kilometers. With this distance, the estimate fuel cost required for distribution is approximately 391,119 rupiah. Additionally, the carbon emission produced are estimated to reach 773,279 grams carbon dioxide equivalent. Comparison of existing routes and new routes using the branch and bound algorithm method with Lingo. The comparison between the existing distribution route and the route generated using the Lingo software with the branch and bound algorithm shows significant results. The existing distribution route used by TBBM Semarang has a total distance of 271 kilometers, while the new route generated by Lingo is shorter at 253.2 kilometers, indicating a reduction of 17.8 kilometers in the total distance. This reduction in distance also results in a decrease in carbon dioxide emission, with a difference of 54,356 grams. For the distribution cost perspective, the existing route includes a cost of 418,695 rupiah, while the new route only requires 391,194 rupiah, resulting in a saving of 6.57%. This shows that route optimization using the branch and bound method with Lingo not only reduces distance and carbon dioxide emission, but is also efficient in reducing distribution costs.
So, for the conclusion, the method successfully reduced the total mileage by 17.8 kilometers, lowered distribution costs by 6.57%, and decreased CO2 emission from 827,635 grams to 773,279 grams, resulting in a total reduction of 54,356 grams of CO2. The optimization not only improves operational efficiency but also helps maintain fertilizer stock availability at gas station, ensuring supply stability while minimizing environmental impact with a more efficient distribution route. Additionally, other factors such as time windows, the number of vehicles used, and external influence should be considered to enhance the precision and effectiveness of route optimization. Thank you.